Whenever people advocate for a language, they always try to answer the question, why this language over others? Why is working in this language a draw for a developer? Today, I want to look at how this question is answered by a relatively new language, one that's in roughly the same space as Rust, C, and C++. It's called Zig, and while it's still under heavy development, it's far enough along to get a sense of what sets it apart. So let's take a look. A key selling point of Zig is that it's supposed to be a better version of C. What's meant by this is that you have many of the things you'd want from C, like manual control over memory, but with safeties that can be toggled on or off. Here's a simple example. If I declare a constant integer, an integer overflow can be detected at compile time in all cases, because the value is static. Now if I set this to a var type, a variable, and compile with safety checks enabled at runtime, the overflow could be caught at runtime, like this. But if I want to selectively turn off runtime safety for some portion of the code, I can use a declaration like this to do exactly that. Now Zig is not intended to be a fully memory-safe language, at least not yet, and there's some discussion about how that could be possible, but it'll be a while before those discussions bear fruit. Right now, though, Zig provides features to make memory management easier to deal with. One of them is the defer statement, where you can declare ahead of time how memory or resources are to be released after we exit a certain context. In this example, we open a non-existent file and try to write to it. The defer ensures that the file handle will be disposed of at the end of the function, no matter what else happens. If we run this, we will get a file not found error, which we then catch, but the file resources are disposed of, and they don't hang around after the function ends. Another key advantage is the way Zig handles the infamous null pointer problem. If you want to define something that could be either a value or a null, you can use an optional type, and the compiler will type check to make sure you don't mistakenly use a null value where you shouldn't. In this example, we're using malloc from libc to get a pointer to memory. But if malloc returns null, we can guarantee that the results have to be unwrapped to be used. That is, the compiler ensures we check the returned value to make sure it's not null. The question mark in the return type for the function means this is an optional value. It's either a pointer to void or a null, with null being a distinct type in Zig. And when we call the function here, the question mark indicates the value is to be unwrapped. So if we run this, we will get our value. But if we substitute in some absurd value for our allocation instead and run it, you can see the result is going to be a null. So Zig's error handling revolves around the idea of returning a value which cannot just be discarded, but has to be handled in some form, and this behavior is guaranteed by the type system. Finally, Zig integrates very closely with C, but without being hidebound by it. If you have a C library you want to use, you can simply import its headers into a Zig program and have them automatically made available. In this example, we can make use of the standard I/O library function printf by using the cimport and cinclude functions. Now, normally we would just use Zig's own printing facilities, but this gives you an idea of how frictionless the process can be for working with C. So to sum up, Zig is meant to compete with C while at the same time complementing it. It has more advanced features for error handling and memory management while still giving you close control over memory. And it integrates with existing C programs and libraries quite seamlessly. That's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.